The overall goal of this procedure is to estimate the dynamics of neuronal oscillations in infant brain structures over a short timescale. This is accomplished by first applying a high-density sensor net to the infant's head and recording brain waves during stimulus presentation. The second step is to pre-process the brainwave data to create event-related potentials. Next, perform a discrete multiple source analysis projected onto an age-appropriate infant MRI template. The final step is application of the source montage and decomposition of the signal into the time-frequency domain. Ultimately, analysis of infant brain oscillations is used to show changes in brain function in early development.
The main advantage of this technique over conventional ERP analysis is that it allows examination of brain oscillations with distinct parameters of frequency, occurrence, amplitude, and time span.
Visual demonstration of this technique is critical as the net application steps are difficult to learn because the actions of the hands, body, and arms in relation to the infant and the caregiver are hard to describe in words.
Demonstrating this procedure will be Teresa Realpe, who's our head EEG technician, and assisting her will be Jess, another EEG person in the lab.
To begin, escort the infant and caregiver into the testing chamber. Sit the infant on the caregiver's lap and have an assistant play with the infant while the net application procedure